Hi friends, welcome to another video in the Dr. USP channel. Today I'll demonstrate confirmatory factor analysis using the free tool Jamovi. Confirmatory factor analysis has a number of advantages. It is used to validate scales and to test hypothesized models. Why is CFA important? It addresses the following questions. Do the items in my survey actually measure the intended concepts? Can 3 or 4 questions reliably measure a single factor like customer satisfaction, for example? These factors are latent factors, and does my theoretical model match real world data? So these are the steps in the confirmatory factor analysis process. First, we define the constructs. Constructs are the latent constructs. Before running a CFA, we need to clearly define what we are measuring. For example, in a study about job satisfaction, the constructs might include work-life balance, career growth, salary satisfaction. Each of these factors should have multiple observed variables, that is survey questions, linked to them. And this is a schematic representation where we have these 3 constructs. You can call them work-life balance, etc., and each of them are measured by the survey questions. So let's discuss an example. For example, if we are measuring employee engagement, we might have 3 observed indicators or 3 survey questions that measure this latent construct, employee engagement. These could be: I feel motivated at work, I actively participate in team activities, I'm satisfied with my job responsibilities. We then need to specify the model, and this is done using statistical software like Jamovi. So we need to specify the number of factors or the constructs, so it could be 2, 3, 4, whatever, and which observed variables load onto which factors. So which of those questions load onto which factors, and the expected relationships between the factors as well, whether they are co-varying or not. And then we assess the model fit. Model fit could be a chi-square test. A lower value suggests a better fit. It could be RMSEA, which should be less than or equal to 0.06 for a good fit, or a CFI, which should be greater than equal to 0.9. Closer to 1 is better, and GFI should also be greater than 0.9 for a well-fitting model. Here are the key assumptions of CFA. Multivariate normality. The data should follow a normal distribution. Adequate sample size, generally at least 200 plus participants. No severe multicollinearity, variables should not be too highly correlated. Random sampling, ensuring generalizability of findings. So here are the key terms we should know about CFA and even SEM models. The first is the latent variable, a hidden concept that we cannot measure directly. For example, intelligence, motivation, etc. Observed variable, a directly measured item, for example the survey questions, which are responded on a 5-point Likert scale, for example. Factor loadings, the strength of the relationships between an observed variable and a latent factor. Then we have endogenous variables, which are influenced by other variables in the model, while exogenous variables like the independent variables act as predictors. We have the Cronbach's alpha, which measures internal consistency or reliability of survey items. Values above 0.7 are acceptable. Today we'll consider the 17-item PTSD scale. It is measured by 17 different questions on a 5-point Likert scale, and we hypothesize that these 17 items load onto 3 latent factors: re-experience, avoidance, and hyperarousal. Re-experiencing is measured by these 5 questions: repeated disturbing memories, repeated disturbing dreams, feeling upset when something reminded you of a stressful experience, suddenly acting or feeling as if a stressful experience were happening, having physical reactions when reminded of a stressful experience. So these 5 observed indicators load onto the re-experiencing factor. The next 7 observed indicators load onto the avoidance latent construct, and this includes avoiding thoughts, avoiding activities, trouble remembering important aspects, loss of interest in activities, feeling distant or cut off, feeling emotionally numb, and feeling as if your future will be cut short. And then finally, hyperarousal is the third factor, which is measured by these 5 survey questions: trouble falling or staying asleep, feeling irritable, difficulty concentrating, feeling overly alert, watchful or on guard, and being easily startled. Let us now see this on a Jamovi interface. So here's the Jamovi interface. In an earlier video, I had shown you how to download Jamovi onto your computer. This is where we'll load our data. So here's the data. I have the SAV file, the one saved from the SPSS application. I'll provide a link to the same dataset in the description below. In the dataset, there are 199 observations. There are 199 people who've responded to this PTSD survey, and there are 17 observed variables as we had shown you, from PTSD 1 to PTSD 17. And each of these, if I click onto this label, I can see that it's continuous data and there is a description for this variable as well. Similarly, for PTSD D2, it's recurrent dreams of trauma. PTSD 3, it's flashbacks. PTSD 5, it's physiological reaction. And if you see these responses, they range from 1 to 5. They are ranged on a 1 to 5 Likert scale. So the data is there. There are 2 ways in which we can analyze that. One of them is through the factor analysis, where we can see the confirmatory factor analysis. But that method probably is not that useful because it does not provide us with a number of measurements that will be needed. So for that, we need to, let's just come back to the data. We need to install a module here, and Jamovi has a number of modules already installed here. These are the default versions: t-test, ANOVA, etc. I need to install another one from Jamovi library, and once it opens up, you can see this SEMLJ, structural equation models based on Lavan. So install this. It's getting installed. So for different functions, we can have different modules like this one. It's being installed here, and now you can see the SEM module on the interface here. Let's open SEM, analysis, SEM. So SEM has these 2 versions: SEM syntax, SEM interactive. We normally work with interactive, which is a very useful interface, very similar to that of other spreadsheet programs that we have worked. Now we know from theory that these are the 17 indicators that measure different aspects of PTSD, post-traumatic stress disorder, and we know that the first 5 observed indicators, the first 5 questions, PTSD 1 to PTSD 5, load on to the latent factor re-experiencing. We hypothesize them as endogenous variables, and let's rename this as re-experience. Now we need to load on these indicators onto re-experience. PTSD to PTSD 5, shift, and let's take all these 5 observed indicators to this endogenous variable. Here it is. Add a new latent. We know the second factor was avoidance or numbing, so let's name it avoidance. With this selected, we'll now drag from PTSD 6 to PTSD 12 as we've hypothesized. These are the 7 indicators which load onto the avoidance factor, latent factor. So we'll have to click onto this arrow, and this is where we get these 7 indicators. The third latent variable, the endogenous variable, is hyperarousal. So let's name it hyperarousal. And let's drag these 5 observed indicators onto this hyperarousal through this arrow. Now there are a number of options which we need to clarify. The first is the path diagram, and for the path diagram, let's click on to path diagram. We want to see the residuals. It's better to go for betas, which are the standardized coefficients. I can have the node size as large. I have these options, and let's see the path model here. So it's getting loaded up. There are a number of layout options here. You can work on the exogenous, could be on the left, on the top, on the right. It can be tree-like, it can be tree-like alt. So tree-like is what most people prefer. So you can go for tree-like. So as you can see here, these three latent factors, they are now described here by this sign is equal to followed by a tilde sign, and re-experience is measured by PTSD 1 to 5, avoidance by PTSD 6 to 12, and hyperarousal by PTSD 13 to 17. This is because this is the Lavant syntax, and as we know that this SEM module on Jamovi is based on the Lavant syntax. Now you can see these are the three latent variables described by these 17 indicators, and this is there on the path diagram. If required, we can copy the path diagram onto our research article or whatever. Now let's see the model fit. We can go for the output options here, and we can have additional fit measures. We can have the Mordius coefficient, we can have the reliable indices, HTMT. If we want, we can have the covariances and correlations. Modification indices is very important, and we'll hide low indices which are below 10, and we'll see how important this is and what is the function of these low indices. Among the parameter options, there's not much. We generally go for automatic. There are a number of options here, so automatic is something that is preferred. Even for the model, the automatic option is preferred. We ask Jamovi to decide which one to take. Generally, we go for maximum likelihood when the multivariate normality is satisfied. Otherwise, we go for weighted least squares or generalized least squares, but it's better to keep the default, which is automatic, and this takes care of missing values. Another option that we have to remember, which is done automatically, is this one: latent variables fix first indicator to 1. Now if you come down to this path model again, right now we have the standardized coefficients, but if on the path model, if you just have the normal coefficients, you will see, if you can see here, the first one is 1, here also it's 1, and here also it's 1. That's because the latent variables, the first indicator has to be fixed to 1, otherwise this measurement is not possible. So it's done automatically by Jamovi. If you're working on AMOS, for example, you'll have to constrain this yourself. Now let's put it back to beta. It's always nice to have the standardized coefficients, because that make more sense. It provides us with more robust comparisons. So here we have the model fit. Let's see how good the model is right here. It has converged. It has converged true, and the estimation method, although we put in automatic, it has taken as ML, maximum likelihood. This is the model which we've already described, and it converged in 36 iterations. If we see the overall test, chi-square, the value is higher, but this is the case when we actually have a bigger sample size like we have here, almost 200. So that is why, although the chi-square test has failed here, we can ignore that. The SRMR is good, it's 0.051. RMCA is slightly higher, it has to be below 0.07. if you remember. The CFI and TLI, they are also less than 0.9. So we need to, although it's a good start, but we need to get it even better. And for that, we'll have to come down to the modification indices. Here as well, as you can see here, the Cronbach's alpha is high 8.862. The AVA is also greater than 0.5. HTMT is higher than we would want to, but that's beyond the scope of today's presentation. Now if you come and see here, this is the most important part that we'll have to remember. So PTSD 9 and PTSD 10, they are co-varying, and it has a modification index of 62.8. So if we come and see here, PTSD 9 and 10, they belong to the same latent construct, avoidance. So we can safely co-vary them, PTSD 9 and PTSD 10. So let's do that on Jamovi. This is where we can co-vary things. These are the variances and covariances. So PTSD 9 and 10, we can co-vary. Let's see, PTSD 9, control, PTSD 10, select them. Now we are co-varying them. Let's see the model. So RMSE has gone much better. It's now 0.081. It still can be made better, but it's on the right path. The CFI and TLI, as you can see, is more than 0.9, and it's closer to what we expect. The chi-square is still bad, but as I said, for larger samples like this, we can ignore the failure of this chi-square test. The CFI and TLI is better. The Holter critical is also better, but it can still be made better by going back to modification indices again. As you can see, the Mardias coefficients is also showing us that multivariate normality has been achieved here, although the discriminant validity is not so good here. Now there's another one, PTSD 10 and 11. If I can co-vary that would take care of some of the discrepancy in the model. So let's co-vary PTSD 10 and PTSD 11. So from this model, using the modification indices, I'm trying to see whether theoretically these covariances are allowed. Now since these things, PTSD 10 and 11, as you can see, they load onto the same construct, we can co-vary them. So these questions, PTSD 10 and 11, correlation between these two, so we can just co-vary PTSD 10 and PTSD 11 here again on this covariances and variances block here. And let's see the model now. So it was 0.81 earlier, RMSEA, because that's what was causing trouble to this model. Yeah, this is much better now, 0.69. In fact, we have reached our goal, which is less than 0.07. So we've reached that. Even CFI is 0.95. So this is excellent fit, as we can see. TLI is slightly lesser than that. So let's see if we can add another constraint there. And if you see here, the constraints are shown over here. So when we are reporting, we can just copy and take it into our report as well, which will suggest, the constraints we have put or how we have defined our model. All the other indices are getting better by just co-varying these two observed variables, the observed indicators. So there are these two options now. We can co-vary 6 and 7, we can co-vary 9 and 11, we can co-vary 8 and 13. Let's see what we can do. 8 and 13 would be different factors, so that would not be the right thing to do. So let's see whether if we can co-vary 6 and 7, and let's see what happens. 6 and 7. So RMSE is close to 0.06, and both CFI and TLI, if you remember, if once it crosses 0.995, it's excellent fit. So what this means is that my hypothesized 3-factor model for these 17 indicators, this hypothesized 3 latent factor structure using these 17 observed indicators has been proved to hold correct for the data that we have. For the 199 survey questions that we had, this model has been shown to have excellent fit with the data that we've provided. So this confirms our factor model, and we can use this to say with certainty that our hypothesis has been proved correct. Thanks for staying along. As always, it was a pleasure having you here. I'll be back with another video very soon. Till then, have a great time.